there was estimated that there were maybe a planet around every 100 stars. Well,
our sun is a star, just like the ones we see twinkling in the night sky. It's a massive, glowing sphere of hot gases, primarily hydrogen and helium, undergoing nuclear fusion at its core. This process releases an immense amount of energy, which radiates out into space as light and heat. It's a giant ball of hot gas that gives off light and heat. The sun's surface, known as the photosphere, is about 5,500 degrees Celsius, while its core reaches temperatures of around 15 million degrees Celsius. Solar flares and sunspots are just a few of the fascinating phenomena that occur on the sun's surface. Our Earth orbits around the sun, and it's the perfect distance for life to exist. This region is often referred to as the Goldilocks zone, because it's not too hot and not too cold. The sun's gravitational pull keeps our planet in a stable orbit, providing the right conditions for life to thrive. But did you know that our sun has a neighbor? Just like we have neighbors in our communities, our sun is part of a larger, stellar neighborhood. It's true, the closest star to our sun is called Proxima Centauri. Located about 4.24 light-years away, Proxima Centauri is part of the Alpha Centauri star system, which also includes Alpha Centauri A and Alpha Centauri B. It's a small, faint star, much cooler than our sun. Proxima Centauri is a red dwarf, the most common type of star in our galaxy. Despite its proximity, it's so dim that it can't be seen without a telescope. Proxima Centauri is so faint that we can't even see it with the naked eye. Its luminosity is only about 0.0017 times that of our sun, making it a challenge to observe without specialized equipment. But even though it's small and dim, it's still a fascinating place. Red dwarfs like Proxima Centauri have incredibly long lifespans, burning their fuel much more slowly than larger stars. This means they can exist for billions, even trillions of years. In 2016, astronomers made an incredible discovery, a planet orbiting Proxima Centauri. This planet, named Proxima b, has sparked a lot of interest in the scientific community. This planet, called Proxima b, is special because it's located in the habitable zone, the region around a star where temperatures are just right for liquid water to exist on the surface. Proxima b orbits its star at a distance of about 0.05 astronomical units, much closer than Earth's distance from the Sun. And as we all know, water is essential for life as we know it. The discovery of Proxima b has opened up exciting possibilities for the search for extraterrestrial life. Who knows what other secrets this neighboring star system might hold? Discovering a planet around another star is no easy feat. It requires patience, precision, and a deep understanding of the cosmos. Astronomers spend countless nights peering through telescopes, analyzing data, and searching for the faintest signs of distant worlds. Planets are tiny compared to stars, and they don't emit their own light. This makes them incredibly difficult to spot against the bright backdrop of their parent stars. Imagine trying to find a firefly next to a spotlight. That's the challenge astronomers face. So how do we find them? The answer lies in the subtle clues left behind by these elusive planets. Astronomers have developed ingenious methods to detect these hidden worlds. One such technique is called the radial velocity method, also known as the wobble method. This method relies on the gravitational interaction between a star and its planet. Imagine you have a giant invisible ball attached to your waist by a rope. As you walk around, the ball would tug on the rope, causing you to wobble back and forth. This is similar to what happens between a star and its planet. As you walk around, the ball would tug on the rope, causing you to wobble back and forth. This wobble is a key indicator that something is exerting a gravitational pull on you. The same thing happens with stars and planets. A planet's gravity tugs on its host star, causing the star to wobble ever so slightly. This wobble is what astronomers look for when searching for new worlds. A planet's gravity tugs on its host star, causing the star to wobble ever so slightly. This tiny movement can reveal the presence of a planet that would otherwise remain hidden. Astronomers can detect this wobble by looking at the star's light. They use sophisticated instruments to measure the star's light with incredible precision. As the star moves towards us, its light waves are compressed, making the light appear slightly bluer. This phenomenon is known as the blue shift. As the star moves away from us, its light waves are stretched, making the light appear slightly redder. This is called the red shift. These shifts in light are crucial for detecting the star's wobble. By carefully measuring these tiny shifts in the star's light, astronomers can infer the presence of an unseen planet. This method has led to the discovery of many exoplanets, expanding our understanding of the universe and the potential for life beyond our solar system. Proxima b was discovered using this wobble method. Astronomers carefully observed Proxima Centauri for many years, looking for the telltale wobble that would betray the presence of a planet. And in 2016, they finally found it. They discovered that Proxima Centauri was wobbling back and forth with a period of just 11.2 days. This meant that there was a planet orbiting the star at a distance of about 7.5 million kilometers, or about 20 times closer than Earth orbits the Sun. From the strength of the wobble, astronomers were able to estimate the mass of Proxima b. They found that it was at least 1.3 times the mass of Earth, making it a so-called super-Earth. This means that Proxima b is likely a rocky planet like Earth, but slightly larger. Because Proxima b orbits so much closer to its star than Earth orbits the Sun, it has a much shorter year. While it takes Earth 365 days to complete one orbit around the Sun, it only takes Proxima b 11.2 days to orbit Proxima Centauri. Imagine celebrating your birthday every 11 days. But even though Proxima b is much closer to its star, it's not scorching hot. That's because Proxima Centauri is a red dwarf star, which means it's much cooler and fainter than our Sun. In fact, Proxima Centauri is so dim that it's only about 0.1% as luminous as our Sun. So even though Proxima b is very close to its star, it receives about the same amount of energy from Proxima Centauri as Earth receives from the Sun. This means that temperatures on Proxima b could be just right for liquid water to exist, if it has an atmosphere, that is. The habitable zone. The habitable zone, also known as the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. This concept is crucial in the search for extraterrestrial life because liquid water is a fundamental ingredient for life as we know it. The habitable zone varies depending on the type and size of the star. For instance, smaller, cooler stars have closer habitable zones, while larger, hotter stars have habitable zones that are farther out. If a planet is too close to its star, it will be too hot, and any water will boil away. This creates an environment that is inhospitable for life as we understand it. The intense heat can lead to a runaway greenhouse effect, where the planet's atmosphere traps more and more heat, making the surface temperatures soar to extreme levels. If a planet is too far from its star, it will be too cold, and any water will freeze solid. In such frigid conditions, the chances of life developing or sustaining itself are drastically reduced. The planet would be a frozen wasteland with ice covering its surface and no liquid water available. Proxima b's orbit lies within the habitable zone of Proxima Centauri. This makes it one of the most intriguing exoplanets for scientists searching for signs of life beyond our solar system. Proxima Centauri is the closest known star to the Sun, and its planet, Proxima b, has sparked significant interest due to its potential to harbor life. This means that if Proxima b has an atmosphere, it could have liquid water on its surface. The presence of an atmosphere is crucial because it can help regulate the planet's temperature and protect it from harmful space radiation. An atmosphere can also provide the necessary gases for life, such as oxygen and carbon dioxide. And as we know, liquid water is essential for life as we know it. Water is a solvent that facilitates chemical reactions, which are the basis of biological processes. Without liquid water, the complex chemistry required for life cannot occur. However, being in the habitable zone is not enough to guarantee habitability. There are many other factors that come into play, such as the planet's atmosphere, magnetic field, and geological activity. These factors can influence the planet's ability to support life. A planet also needs to have the right kind of atmosphere. The composition and thickness of the atmosphere are critical in determining whether the planet can maintain liquid water and support life. An atmosphere that is too thin or too thick can create extreme conditions that are not conducive to life. For example, if a planet's atmosphere is too thin, it won't be able to trap enough heat, and the planet will be too cold for liquid water. This would result in a barren, icy world where life as we know it would struggle to survive. On the other hand, if a planet's atmosphere is too thick, it could create a runaway greenhouse effect, making the planet too hot for liquid water. This would lead to scorching temperatures and an environment that is hostile to life. Therefore, finding a planet with the right balance of atmospheric conditions is key to discovering potentially habitable worlds. So is there life on Proxima b? It's a question that fascinates scientists and dreamers alike. Given its position within the habitable zone, where liquid water might exist, the potential for life cannot be ruled out. However, the planet's extreme conditions, such as frequent stellar flares from its red dwarf star, pose significant challenges. Still, the possibility remains, and future missions might one day provide us with answers. Traveling to Proxima b presents monumental challenges. The distance alone, over 4 light-years away, would take current spacecraft tens of thousands of years to traverse. Advanced propulsion technologies, such as nuclear fusion or even theoretical concepts like warp drives, are required to make the journey feasible within a human lifetime. Additionally, the vast amounts of energy needed and the unknown effects of prolonged space travel on the human body add layers of complexity to this formidable task. Despite these challenges, humanity has always been a species of dreamers and explorers. Imagining a future where we can travel to distant stars and perhaps even colonize new worlds is a powerful motivator. Technological advancements continue to push the boundaries of what's possible, and one day, the dream of interstellar travel might become a reality. The idea of reaching Proxima b and discovering its secrets keeps the spirit of exploration alive. Could Proxima b be a new home for humanity? While it's an exciting prospect, the reality is that many hurdles must be overcome. From developing the technology to get there to ensuring the planet can support human life, the journey is fraught with challenges. Yet the potential rewards are immense. A new world could offer humanity a fresh start, a chance to expand our horizons, and perhaps a new chapter in the story of human civilization.